Okay, let's have a example of the LCR question together. Okay, this is at the SciPad 346. Okay, question 4. Okay, I think this probably will put everything together slightly. Okay, and see how it goes. So we have a LCR circuit, and we got a resistor 48 ohms, and we got a capacitor 87 micro F and 85 mH. Okay, inductor, and we have a power supply which is 65 hertz, and the peak value. Okay, peak value. Okay, peak value. Peak voltage of the power supply is 18. Okay, so what you can think after you read the question, I think we will need to do the reactance of XC, okay, and the reactance of XL. Okay, peak value, we don't know whether we need to do the RMS value or not. Okay, but this is something you can be think of. Okay, another one is they give you hertz. Okay, they give you hertz. Okay, and you need to know roughly we need to use omega. Okay, angular frequency. Okay, depends on the question. Okay, so this is roughly you can get from read the question. Okay, so now let's do the question. So sketch the circuit in a space below. Okay, so we are going to draw a circuit. So what do we have? We have a power supply, so this is AC, okay, and we have LCR. So what do we have? We can have a resistor, a capacitor, and an inductor. Okay, inductor. You can put one more line here, okay, to make the inductor more obviously. Okay, so it's peak value. Then we can put probably some numbers. So VP peak value is 18 volts. Okay, and frequency is 65 say hertz, and resistor R is 48 ohms. Okay, and capacitor C is how much? 87 micro F. Okay, and inductor will be L. L is what? L is 85 mH. Okay, so this is the thing we have, the circuit. The second one, they want you to what? They want you calculate the inductive and the capacitive reactance. Okay, so now we know XC is what? XC, okay, so reactance, it is inverse proportional to the frequency, remember? Okay, and XC. Okay, so this will be XC. Okay, then we can put a number in. Okay, inverse proportional to the frequency and the capacitance. So 1 is here, and omega is how much? Omega is 2 pi times F. F is 65. Okay, and C is how much? C is 87, and micro power of -6. Okay, so this is will be our number, and you do the calculator, and it will be 28 ohms, 28.1. Okay, 28.1 ohms. Okay, and how about XL? Oh, XL is how much? XL will be proportional to the frequency and the inductance, so we can put number in. So it's 2 pi 65, and then that would be how much? 85 mini. Okay, -3. So the answer is 34.7 ohms. Okay, so write the answer to the box. XL is 30, rounded to 35 because we only got two signal figures here. XC is 28 ohms. Okay, now we want to determine the impedance. And remember, how do we do the impedance? Okay, impedance is Z equals to R squared and plus what? XL is bigger, so XL minus XC squared, and take the square root. Okay, so we put a number in. R is how much? R is 48. Okay, XL is how much? XL is 35. 28 square root. Okay, and the answer is how much? The answer is 49 ohms. Okay, find the peak value. Okay, so we want to find the peak value of the current. Okay, that around the circuit. Okay, so we know what? We know V equals to IZ, like Ohm's law. Okay, and they tell you what peak value of the voltage we know already. So we want to do the peak value of current, so we don't need to convert this one to RMS value. Okay, but this is the formula we are going to use, and then we can rearrange. We want to know the peak value of the current will be equals to VP over Z, and VP from question is 18. Okay, and Z is how much? Z is 49. Okay, so from the calculator we can get this is how much. This is 0.37 amp. Okay, and now they want you calculate the peak value across. So again, we still do peak value. Okay, and VR, VC, and VL. Okay, so this is like Ohm's law. Okay, so VR is IR. So we do peak value. We don't need to convert this one. And if you want, you can put a small p here. Okay, and X VC will be what? Will be IPXC. Okay, and VL will be IPXL. So now we can put number in. It's easy. So IP is how much? IP is 0.37. R is how much? R is 48. Okay, and 0.37. XC is how much? XC is 28. Okay, and XL 0.37 and XL is 35. Okay, so from calculator you can get V here is 17.8 ohms, and VC is how much? VC is 10.4 ohms, and VL is how much? VL is 12.8. Okay, and you can round them into two significant figures. So this will be 18. Oh, I can put in red there. Okay, so this will be 18 for VR volt. VC, or yes, the unit is wrong. So here is V. So V. Okay, 11. VC is 11. And VL is 13 volt. Okay, so this is the example that we put everything together.